Hey guys, go ahead and get out your note sheet 494, factoring to solve quadratic equations. So to make sense out of how we're going to solve our quadratic equations, the zero product property helps. So our zero product property states that if a times b equals 0, then either a equals 0, b equals 0, or both a and b equals 0. Since any number times 0 gives you 0, then it could be a or b, or technically both of those could be 0 to give you 0. So our steps for solving a quadratic equation using factoring would be to put the equation into standard form first, and standard form would be ax squared plus bx plus c, and now we're adding an equals 0 since we're now making these into equations that we're going to solve. So you want to basically have everything on one side and then 0 all by itself. Once that happens, you're just going to factor using your normal factoring steps. So this would be GCF, and then a times c, and find the factors that would give you b, and get your answers from there. And then once you have your factors, you set each of your factors equal to 0, and then you would solve for what x or whatever the variable would be. And then we could do our check by plugging our answer back into the original equation, or we can use your calculator, and I'll actually show you guys how we can do that later on, to actually graph it and look into the graph of this to kind of verify your solutions. So we're going to start off really basic. These are already factored. This is just getting the understanding of how we're solving these to get the answers. So if we have something like x plus 3 times x minus 5, and again, these are already the factors of some kind of quadratic equation, using that zero product property, we know that if you have two numbers multiplied by each other and they equal 0, that one of them has to be 0. So, or both of them can be 0. So we're going to assume that maybe both are 0. So we're going to figure out what x could potentially be in either of these two little binomials in order to give you 0. So basically what you do is you take your first factor and you set it to 0, and then you take your second factor and you set it to 0, and you've just created two mini one-step equations, and you're going to just solve for x in both of these. So if I'm going to solve for x in this first one, I would subtract 3, and I'm going to get x equals negative 3. That's one possible value that's going to make this equation equal 0. Or I can add 5, and I'm going to have x equals 5. So what that tells me is that negative 3 or 5 could be solutions here, and a solution is a 0, and it's also called a real root, and it's basically a value that you can plug into the original trinomial, which we actually don't have here, and plug it in for x, and what it's going to end up giving you is 0. So both of these are answers. Make sure you use the braces and not regular parentheses, because then it looks like an ordered pair. These are two separate solutions, so you want to show it that way in braces like this. Second example, again, this is already factored, so we're just getting the understanding of how to get the zeros. So you're going to take each factor and set them to 0, and then we're going to solve for the variable in each of these binomials. So on the left, we would solve for a by subtracting 5 and then dividing by 2, and we're going to end up getting a equals negative 5 halves. So that's one of the possibilities that would make your solution 0. And then you would subtract 7, and we would get a equals negative 7. So our two solutions, or we call them zeros or real roots, would be negative 5 halves and negative 7. And again, that means if those go into the original trinomial, which we don't have since these are already the factors, then you would get 0 when you plug either of those in. And this third one's looking at having a GCF. So there was technically in this original trinomial a GCF first of t, and then the factors of the rest of that made 3t plus 5 and t minus 3. So the rule is to set each factor to 0, and technically in this case we have two binomial factors, but the GCF also counts as a factor. So we're also going to take that GCF and we're going to set that to 0. So that's going to end up giving us 3 solutions here instead of 2. So t equals 0, you're kind of already done. You don't have to solve for t there. And then in the next two, we're going to solve for t. So I'm going to subtract 5, and then I'm going to divide by 3 in the first one, and I'll get t equals negative 5/3. And then in your last one, you'll add 3, and we'll get t equals 3. And so we have 3 solutions, so when we do our braces, we would just put all 3 of them. Order really doesn't matter here. I'm just going to put them as is. So 0, negative 5/3, and positive 3 are your solutions for this. Go ahead and try this last one on your own and press play when you're ready to check. And you should have ended up with option 1, that negative 3 halves and positive 3 are your two solutions when you set each of these factors to 0 and solve. Next thing we're going to take a look at is when you actually have to factor, and it's really just adding and factoring now, and then you would take your solutions or your binomials and set them to 0 like we just did. Okay, so what we're looking at is taking this and setting it to 0, which it already is, so then we're ready to factor, and then once we factor, we're going to go ahead and split the factors and set them to 0 and solve and check. So when I go to factor this, it's a binomial right now. I'm looking for a GCF always first in every problem, so there is a GCF of x, and what that's going to leave me is with x and then x minus 11. Now, you also want to look at this leftover and see if there's any way you can potentially factor more from x minus 11, but I really can't do anything. There's nothing, this is not a difference of squares, and there's nothing else I can do. So at that point, you're technically done factoring, and we're going to take these two factors, your GCF and the x minus 11, and set them to 0. And then we're going to go ahead and solve for our solution. So I already have 0, and then I'm going to add 11 in the other one, so my two answers here become 0 and 11. Okay, next one we're going to look at factoring first and then setting our factors to 0 to get our solution. So again, you're going to look for a GCF. There is no GCF here, so we're looking at the factors of AC, which is 20, that give you B, which is negative 9. And you can list your factors of 20 that are going to end up giving you negative 9, and it should end up being 4 and 5, both of those negatives. Now, naturally, you would want to potentially do box method or guess and check if you have a number in front of your A, if A is greater than 1, but we don't, so we can now just actually use these as our two factors, as x minus 4 and x minus 5. We don't have to do box method, and if you don't believe it, you can always FOIL and check, and you're going to end up getting that trinomial, which means now we're going to go ahead and split our factors and solve for our solutions. So we're going to set each to 0, and I'm going to end up with a solution of 4 and a solution of 5. So again, what that means here is that if you were to plug in 4 for x into this original trinomial, it's going to give you 0, and if you plug in 5, it's also going to give you 0. So I'm going to go ahead and put that on here so that you guys can kind of see that this would be how you would check these. So you can see the check shown. I plugged in 4 in red here, and you can see that it's going to give you 0, and then I plugged in 5, and it's also going to give you 0. So your solutions are meant to give you 0 because we have set this equation at the top equal to 0, so we know when we plug these in, we should get 0 on both sides, and that's another reason why these are actually called solutions or zeros, and then also real roots when we look at the graphs. All right, so number 7 is ready to be factored. It's already in standard form, so we're looking for a GCF first, and we do have a GCF of 3x, and once we take out 3x, we should have 2x squared minus x minus 3 equals 0, and then we're going to go ahead and look and see if we can continue factoring that middle trinomial. So our factors would be, or we would do a times c, which is negative 6, and then b is negative 1. And I already know factors of negative 6 that should give me negative 1 or negative 3 and 2. So at this point, if you're a box method person or a guess and check person, this is what you're going to go ahead and want to do from this point, and then press play when you're ready to move on. So you should have ended up with factors of 2x minus 3 and x plus 1. So I write those out with my GCF, and now I'm ready to split and set each of my factors to 0. Keep in mind 3x, your GCF is still a factor, so we're going to set that to 0. 2x minus 3 to 0, and then x plus 1 to 0. And I've got 3 mini equations that I'm going to go ahead and solve for x in each and get my solutions. So I should get from my first one, x is 0. From my middle factor, I get x equals 3/2, and then for my last factor, I get x equals negative 1. So again, keep in mind that what that means is that all 3 of these technically now can get plugged into that original trinomial up at the top, and you would end up getting 0 on both sides from those. Something to help you guys and keep this in mind when you're going to end up getting 3 solutions versus 2 versus maybe even 1. The highest degree that you actually have will tell you how many solutions you should get. So if I started here with 6x cubed, that means I should end up with 3 solutions instead of 2 at the end. So that's kind of a nice little way to help you at the end kind of reflect on your solutions versus that original trinomial. Go ahead and pause and try number 8 on your own, and then press play when you're ready to check. So you should have had the GCF and then had r squared minus 4, which is a difference of squares. So we end up with r plus 2 and r minus 2. And we end up with the 3 solutions of 0, 2, and negative 2, which is option 5. And if you were just paying attention to what I said on the last problem, because we started off with this cubed as our highest degree, that tells you that you're going to end up with 3 solutions. So you could have potentially eliminated options 1, 2, and 3 right from the beginning because of that. And the last few things we're going to look at is whenever you have to put your equations into standard form first and then solve. So your first example here, you can clearly see we don't have standard form. So what we're going to want to do is put standard form. And with standard form, you always want a to be positive. So right now, my x squared or my a squared term is over on the right side, and it's a negative. So that tells me that I'm going to want to actually get that one to move over so that it becomes a positive. So if I'm going to move that negative a squared over, I'm going to add it to both sides so it goes away from the right side, and then it moves to the left-hand side, and so that it's going to end up becoming a positive a squared. The minus 24a and plus 144 stay the same. And now that you've got standard form, you're ready to factor. So we look for a GCF, which there is none. We're going to do a times c, which is 144. And I'm kind of already thinking that a and c right now are perfect squares. And so I'm realistically looking for my factors of 144 that are going to give me negative 24. And this is actually a perfect square trinomial since I have two perfect square numbers and my last number is a positive. So I could technically just square root each of these, and I get a and 12 and 12, and they're both going to be minuses to create that negative 24 in the middle. So I'm going to take each of these and set them to 0 now so I can get my solutions. And what you should be thinking of already is that, wait, these are the same, two binomials, so I'm going to get the same answer twice. So that is true, and that's going to actually mean something when we look at the graphs of these. There's technically only going to be one solution to this. Now, I know I had said that degree tells you how many solutions, and I mean, really, we did get two solutions, but because they were exactly the same number, you don't have to repeat it twice. So this really just gives you 1, 0 when you would look at the graph of it. Okay, number 2, again, we would want standard form first. So you always want your a to be positive, and right now a already is positive, so keep that where it is. We're going to have to get this 20 to move over. So it's a positive 20 right now, so we're going to subtract it, which will make it a negative 20, and then positive 25, and then we have 0 left over on the right side when we move over 20. So at this point, we're ready to factor. We would look for a GCF. I don't see a GCF, and so we would do a times c, which is 100, and b is negative 20. And we would start looking for factors, but again, I'm kind of looking at a and c right now, and they're both perfect square numbers, 4m squared and 25, and this is positive, so I'm thinking that maybe this is another perfect square trinomial where I can just square root a and get 2m, and square root 25 and get 5, and then test and see if that middle term is those two multiplied and doubled, and it is. So again, this is another one where we've got the same two factors, which means I'm going to get the same two solutions whenever I solve. And again, I know my degree was 2 here, which tells you should have two solutions, but when you have the same two factors with a perfect square trinomial, you're always going to end up with only one solution. So 5/2, and that's it. Go ahead and try this one on your own. So press pause. You're going to want to put it in standard form first, and then you'll factor and solve and then get your solutions. And something to keep in mind here is you've got this cube here, so that should tell you you end up with 3 different factors and 3 solutions at the end. Okay, so you should have had a GCF of x, and then you were able to factor. AC was negative 15 and B is 2. Your factors would have been negative 3 and 5, and because there's nothing in front of your x squared or A is 1, you're able to just use those as your factors. And then we end up with our 3 factors and 3 solutions of 0, then negative 5 and positive 3. Go ahead and pause and try number 4 as well. You should get one of the 4 answers over here, and then press play when you're ready to check. Okay, so standard form, you would have subtracted over 40, and then your factors of negative 40 that give you negative 3 should have been negative 8 and 5. And again, because A is technically 1 here, you don't have to use box method. You could just factor, and then we end up with our solutions as 8 and then negative 5, which is option 2. Last thing we want to look at is a couple word problems. So number 5 says Maria told this puzzle to her friends. The product of 4 times my age and 45 less than 3 times my age is 0. How old am I? So we're looking for Maria's age, and we're going to let our variable stand for Maria's age. So we're going to kind of write this out as an equation, and we're going to solve. So product, first of all, is multiplication, and she's saying the product of 4 times her age, which is going to be m. So that's going to be 4m. And, so this is what we're multiplying by, 45 less than 3 times my age. So if it's 45 less than, that was your key earlier this year where we're actually going to reverse this, so it's minus 45. 3 times my age would be 3m. And then she says that that product actually is equal to 0. So the nice thing about this one is since the problem already is set to 0, that's technically already standard form. And on the left side, I don't need to redistribute, because if I redistribute, I'm just going to have to factor out that GCF. This is already in factored form for you. So we're going to just take each of these factors and set them to 0, and we're going to solve for Maria's age. So the first one's going to give you m equals 0. So you're saying Maria equals 0. With word problems, you're typically going to have one answer that doesn't make sense, and it doesn't make sense to say Maria 0. So that's not going to be your answer. And remember, with that zero product property, we just need one of these to be true. So we're going to try the other one and see if we get an answer that makes a little bit more sense here. So 3m should equal 45, and if we divide by 3, then we're saying that Maria's 15, and that makes definitely a lot more sense than saying Maria's 0. So in this case, we get rid of the answers that don't make sense on word problems. We keep the ones that make sense. So Maria is 15. Number 6 says to find two consecutive integers whose product is 240. Keyword here is consecutive, and consecutive means in a row. So we're saying two numbers in a row that were multiplied together is going to equal 240. So we're going to pick a variable to represent these, and so if I let n represent my first integer, then the number that would be consecutive with n is going to be 1 bigger than that. So I'm going to represent that by calling it n plus 1. And that says that the product of these two is equal to 240. It's basically two numbers that are only one space apart multiplied to give you 240. Now, this problem's a little different than the last because this is not true standard form. Since this side does not have a 0, we're going to have to actually put this in standard form. So what I'm going to do is I'm going to have to distribute my n, which is going to give me n squared plus 1n, and I'm also going to have to subtract over the 240 because I need it to come over here to be in true standard form so that I can actually factor this problem. The last one, because it was already set to 0, we didn't have to do this, but this problem we will. So now we're looking for the factors of AC here that are going to give me B, and AC is negative 240, and then B is 1. So this one might take a little longer to find those factors. I mean, realistically, I don't have to think about 1 and 240 and then 2 and 120 because they're not one space apart. So I'm going to start picking numbers that maybe are a little bit bigger and try and hopefully find one. And the first group that I tried actually worked. So 15 and 16 multiplied to negative 240. And then when you combine negative 15 and 16, you will get 1. So I would know my factors then are n minus 15 and n plus 16. And then I'm going to go ahead and solve for these as solutions, so I'll set each to 0. I'll get one of mine to be 15, and my other one to be negative 16. So because this word problem did say find two consecutive integers, integers can be positive or negative whole numbers, then both of these technically will work, because if 15 was n, then 16 is n plus 1, your next number, and those are going to multiply to 240. And then if n was negative 16, one bigger than that's negative 15, and those two negatives will also multiply to 240. So both of these are your solutions here. You want to keep them. Last thing we're going to look at is an area problem. So this says Leonard's room is 6 feet longer than it is wide, and the area of his room is 160 square feet. Find the actual dimensions of the room. So we want to start with, again, identifying our variables. And so I know I'm trying to look for the length and the width of the room. Those would be your dimensions. So for this one, we'll let W be the width of the room, since that's truly what you don't know at all. And then we know that the length is 6 more than that, so the length would be represented by W plus 6. I always suggest on any kind of picture problems to definitely draw one, especially if it's a shape problem. So this is saying that your width times your length, which we know is 6 more than the width, or W plus 6, gives you an area of 160, and that's how we're going to set our equation up. So area of a rectangle is length times width, but I'm going to go ahead and put the width first. It doesn't matter the order there because of commutative property. And we're going to go ahead and solve. Now, again, this is not standard form because this 160 is a 160. That would need to be a 0. So this is like the last one. We're actually going to have to distribute the W and then bring over that 160, which is going to make it a negative 160, and then set this to 0, and then you can actually factor. So now I'm looking at factors of AC, which is negative 160, that are going to give me 6 for B. And I definitely overthought those factors. So to multiply to get negative 160, you can do 10 and 16. And then to add to get 6, you would need negative 10 and 16. So our factors, because again, A is 1 here, these can just be used, would be W minus 10 and W plus 16. We're going to set those to 0 and get our solutions. So I end up getting two solutions. One is positive 10 and one is negative 16. Since W in this represents the width of this room, it does not make sense to say that the width of the room is negative 16 feet. So we're going to go ahead and get rid of that answer, which tells us that the width would definitely be 10. And then if the length is 6 more than that, then the length is 16. And then I know if I multiply 10 and 16, I do get that area of 160. So that is it for these. So we will practice more of these whenever I see you guys again, but hopefully that wasn't too bad. It's really just adding another step to factoring.